So here in the last part of chapter 7, we're talking about inverse functions. Now an inverse function maps the output values of one function to the input values of another function. Okay. Here we're using the word relation. I said the word function. The reason I'm talking about a function versus a relation, remember a function has to pass the vertical line test. So if I were to have a picture like this, kind of a sideways parabola, this would not pass the vertical line test, so this would not be a function, but it would be a relation because it describes the relationship between the x and the y values. So if you do have a graph that looks like that, it's not a function, but it is a relation. We know parabolas like this are functions because it does pass the vertical line test, only crosses once there. So again, when I'm talking about a function, I'm talking about something that passes the vertical line test. If we're talking about a relation, the relation doesn't necessarily have to pass the vertical line test, okay? But again, all we're saying here is that the output values, again, output, that's my y values, map to the input values, those are my x values, of another relation, okay? So basically, we're switching the x and the y values. Now, when we write the function, again, let's say we have f of x here. Again, that's literally said f of x. I wrote that out in the red there. The inverse function we label like this. So it's got that exponent of -1, but this actually just reads as the inverse of f of x. So one thing I don't want you to get confused about is that, let's pick a new function. Let's just say inverse of g of x. Okay, this is not the same thing as 1 over g of x. Okay, I know we just got done talking about how negative exponents mean you're going to have to move that base to the denominator and make it positive, but that is not the case, okay? So do not think about inverse functions like that, okay? This -1 here, all it does is it tells you we're looking at the inverse. This -1 does not tell you have to move anything to the denominator or anything like that, okay? So again, even if I had, p of x, the inverse would be the inverse of p of x, and that is not the same thing as 1 over p of x, okay? So don't do the 1 over p of x. All you have to know is that this is your function p of x, and the inverse is called the inverse of p of x, using that exponent of -1, all right? So that's what we use. Again, function is called f of x, inverse is just like this here with that -1 exponent. All right. Another way of thinking about inverse functions, we said that the output values get mapped to the input values. In other words, our x and y values are just kind of switching. So here I have a blue function and I have a red function. Notice they're both functions because they both pass the vertical line test. But if I were to think about, let's just pick a point on one of these graphs. Let's pick a point right here. Maybe this is like 5, sorry, let's say 2, 5, right? 2 to the right and then 5 up. That means that the point here, which is 5, 2, would also be in the inverse function, okay? Notice how your x and your y values just switch places, okay? Basically, another way to think about this is that it's reflected across the line y equals x. So this kind of has a mirror image happening as you flip it, all right, as you reflect it across that line y equals x there, okay? So it's kind of this mirror image thing happening across this line y equals x. Right. So to find the inverse function, you're going to switch the x and the y values, and then you're going to solve for y. So to do that, we can rewrite this first problem as y equals 2x minus 11, because we know that p of x is just the function, so that's my y value. So I'm going to switch the x and the y values, and then I'm going to solve for y. So let's go ahead and make that switch. So now I have x equals 2y minus 11. All right, so we've done the switch. Now I'm going to go ahead and solve for y. So I'm going to have to add 11 on both sides. So now we have x plus 11 equals 2y. Now what I want to do is I want to go ahead and I want to divide both sides by 2. And now we end up with y equals x plus 11 over 2, okay? I want to write my final answer, letting me know that it's the inverse function. So I'm going to say p, I'm going to use that -1 exponent. So I'm going to say the inverse of p of x. That's how we would say this. Please do not say p to the minus 1x, don't say anything like that. Just say inverse of p of x. All right. The inverse of p of x is going to be x plus 11 over 2. All right. And that would be your answer. So I want to take you over to Desmos and kind of show you that what we just talked about makes sense, right? We just took this function, 2x minus 11. We can see that's the red line. And I have this dotted black line. That dotted black line is y equals x. And if I graph what we just got, right, we just got x plus 11 over 2, we can see that there's this mirror image happening, okay, across this line y equals x. And so basically I could pick, any number I want on, any point that I want on the red graph. So let's go ahead and let's pick the points -3. Let's see, if I plug in -3 for x, that would give me -17 for y. All right, we're going to label that. And so we get this point -3 comma -17 on the red graph. So if I switch the x and the y values and I write -17 comma -3, we do see that in fact we get that point to be on the inverse function, which is that blue line. Okay, so notice when you flip the x and the y values, you should see kind of that symmetry, that reflection happening. Okay, so that's kind of how it works. All right, it's a good way to check your answer as well. So now we're going to do the next one. Next one is m of x equals x squared plus 4. So here what we're going to do is we are going to go ahead and replace m of x with the letter y, because it's the same thing as y. So we've got y equals x squared plus 4. All right, I want to make a switch. I'm going to switch the x and the y values. So now x equals y squared plus 4. I'm going to subtract 4 on both sides to try to get the y all by itself. And now we've got x minus 4 equals y squared. Well, I know that to undo a square, I'm going to have to square root both sides. So we're going to square root the right and square root the left. And we end up with y equals, but remember when I take the square root of both sides, I have to consider both the positive and the negative, okay? There's nothing I can do with that x minus 4. I can't, tempting to want to take out a 2, but you cannot take out a 2, okay? You cannot do it because this is part of a binomial, okay? If it was 4x, yeah, well, the square root of 4x, then I can take out a 2, and that would become 2 square root x, okay? But because we have that minus sign in there, I have to keep those two terms together, right? Order of operations. So that means that we know the inverse of m of x is going to be plus or minus the square root of x minus 4, okay? So that would be our answer, all right? Now, again, what we're thinking about is when we look at the graph of this, okay, if I were to only consider the positive, here we've got that x squared plus 4 function. Okay, that's a parabola. All right, we know it's quadratic, so that's what it looks like there. If I were to only consider the positive, notice how we do have that mirror image happening, right, reflecting across the line y equals x. But if we forgot to do the plus minus, we would only get that positive output values. If I also consider the negative, then you can see we do have that parabola that is in fact reflected across the line y equals x, okay? So notice that if I take my inverse function, inverse of m of x is equal to plus or minus the square root of x minus 4, notice that this is actually not going to be a function. So my answer here is an inverse relation, but it is not an inverse function, okay? Again, it's not an inverse function because it does not pass the vertical line test. I could draw a vertical line and it would cross twice, all right? So yes, plus or minus the square root of x minus 4, that is an inverse relation, but it is not an inverse function, okay?